Hello everyone. This is the third video of our first week. In this video, I'm going to show some advanced computations by using Python. As usual, we are going to use Anaconda Navigator. From the Anaconda Navigator, we will choose Spider we will use the Spider notebook or Spider editor to write code in Python. Okay, let's get started. Let's get started, and let me open Anaconda Navigator. It take maybe 1 minute to get Anaconda Navigator to be opened. Okay, now I will open Spider. I will launch Spider. Okay, so now let me go and Control A, delete. I want to open now part 2. Here is my week 2. Let me change it to rename desktop. I want to open this on part 2. Okay. So in this part 2, there are, I guess, 25 or 30 problems. I have to check how many. There are altogether 30 problems. Okay. So these 30 problems now we are going to solve by using Python. So this will conclude the materials of our first weeks. So basic computations and advanced basic computations and how to install Python. These 3 videos is enough to get started with the Python. Okay. So write R code for each of the following function and evaluate them for x equal to this, y equal to that, and z equal to that. So instead of R, let me change it to Python. So we have to go there. We have to go there, and these are the all packages built by some other people. I'm going to use this package, and this is the way you can import the packages in your Spider in Anaconda Navigator. Spider in Anaconda Navigator, this is the way you can bring these packages. So NumPy, math, and random, matplotlib, matplotlib.pyplot, these are all packages developed by some other people which we are going to import. Okay, which we are going to import. So let me take like that way. So again, so I run this transfer or import these packages in the Python. This is called the editor, and in this editor I will write, I will save, I will edit all the code. Finally, this is the savings, and in order to get the output, I have to transfer the code from this editor to console. How can I do this? I have to select either the cursor will blink on one line. That line, if you want to transfer, just control enter or command enter. Command enter for the Mac people and control enter for the Windows people. The people, the students who are using Mac computer, they will hit command enter in order to transfer the code from editor to console. Okay, so now the previous two videos I mentioned that this is the last time I'm mentioning. If your control enter or command enter does not work, what you are going to do, you go to the tools and go to the preferences, and from the preferences select keyboard shortcut, and keyboard shortcut from there come in here, run cell. Are you seeing run selections? Do the run selection in here, check it, click in there. So like this, so you just this in here, and then you hit in here, this new shortcut, you hit in there, and then you do the control enter, and then control enter is in there, you put here okay, and then hit okay, then apply, then hit okay, then run selection will work. Now if I want to run this, it is running. Okay, so all of this code has been run. Now let me take you to the Word document. Word document is saying that I want to evaluate these three functions for these values x, y, z. So I have to declare x, y, z. This is my A, this is my B, this is my C. Okay, this is my A, this is my B, this is my C. A equal to what? Take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y equal to, so like this, X, Y, Z. So I created here A, X, Y, Z. I can also create here X, Y, Z. Let me write here X, Y, or I can put here, let me see. Yeah, X, Y, Z is fine. I can put here Y, and then I can put here Z. Okay, so this is the three things I have declared in there. So now this is the data. So now I have to write a function def, that means definition, f1a function 1, which has an argument x, and the result is 5x plus 10. I write here 5x plus 10. If you take a look at that, 5x plus 10, 5x plus 10 I have written. So I have written here 5x plus 10, and I name it as a results. So this is a function I have written. That function I give a name f1a, and which has the argument x. And then finally I got return these things. This is the way you will get the function. Now I want to change this a to x. That x I declared in here. That x I declared in here. Okay. So that x I declared in here. Now if I want to run this, I will get this number. So 15. Let us check. How did I get 15? If I plug x equal to 1, 5 times 1 equal to 5 plus 10 equal to 15. This is the way I got 15. So how did I get 60? So if I put x equal to 10, 5 times 10 equal to 50, 50 plus 10 equal to 60. So that is why I got here 60. Okay. So now come to the second one. Change it to x and y. And this is a function with two arguments, x and y. X plus np dot exponentiation of x minus np dot log of y. If we write this, we will get that one. And then finally, if we change it in here, x, y, z. So this is the third argument. So let me explain this thing. This is argument with two arguments, x and y. So the function was x plus e to the power x minus log of y. This is the function x plus e to the power x minus log of y. So I put here x plus np dot exponentiation of x minus np dot log of y. So, and then if it is run like this, and similarly, this is a function for 3 argument, which also has a phi to the power x, 17x, and log of z. Log of z. These are the things is in there. So we can find this function as well. So what you have learned from the first question, which is a 3 functions with 1 argument, 2 argument, and 3 argument. Now from these lines of codes, for the first problems, you have learned how to write a functions and how to evaluate a functions for a one value or from for a range of values. This is what you have learned from this first problem. Okay, now let us discuss second problem. Second problem is solving linear and quadratic equations. Okay, linear and quadratic equation. 3x plus 5 equal to 0 is a linear equation. X in the equations involving x square are quadratic equation. We want to solve these 3 quadratic equations. Okay. So there is a package known as system of linear equations. So it has a name, system phi. System phi is the package someone else developed. I imported it as a shortcut name SYM. So let me import the package and then I want to find the solution. Solution is system.solve 3x plus 5. I want to solve it for x and then I write here solution equal to x. This is the way we got the solutions. And then if I want to run this, we got the solutions -5/3. Similarly, that is the quadratic equations. I want to solve it. That is the way I got the solution. This is the quadratic equation. I want to solve it. I got these solutions. This is the quadratic equations. I solved the equations. I got this thing. This is the imaginary root 1. You remember minus b plus minus square root of b square minus 4ac divided by twice a is the solution of any quadratic equations. So there is a package known system phi developed by someone's. I'm using their package and I'm getting the results. Okay, I'm getting the results. Question 2 is done, which is a 3 part. Now question 3 involves 2 matrices A and B. Of course, square matrices. If number of rows and number of columns are the same, then a matrix is called square matrices. Otherwise, the matrices are called the rectangular matrix. 2 square matrix we will use here to add the elements of 2 matrices, subtract one matrix from another, multiply one matrix by the other, finding the determinants of the matrix, finding the inverse of the matrices, finding the rank of a matrices. Okay, find the rank of the matrix and find the transpose of the matrix. Okay, let us start first reading the matrix A and matrix B. These two matrices ranging from line 56 to 62 are transferred to the console and the matrix we see. Now, if I write here A, this is the matrix A. If I write here B, now the matrix B. Okay. Now, this is just the addition of 2 matrices, which is just element wise. For example, if you add 7 with 9, then you will get 16. Here is the 16 element wise. So, and this is the subtraction of matrix B from matrix A. This is the element wise multiplication. So there is the 2 types of multiplication. One is called the element wise multiplication and another one is called like the real matrix multiplications. Columns of a matrix will be multiplied by the rows of a matrix. This is called the matrix multiplication. But that one is called the element wise multiplication. For example, A and B, if you multiply, so first element will be 63. So here is 63. So if you multiply 5 times 3, then 15. That is a 15. This is called the element wise multiply. And that is the real matrix multiplication, which is you multiplied this row, this column by that row. For example, 9 times 7 equal to 63. 5 times 7 equal to 35. So 35 plus 35 plus 63 equal to 98. 98 plus 4 equal to 102. So this is a 102. This is a 102. So 102 is coming. These 3 will be multiplied by that. 7 times 9 plus 5 times 7 plus 4 times 1 will give us 102. Okay, so now after matrix multiplication, I want to find the determinant of the matrix. So this is the way determinants of the matrix can be found. So you know about this, how to find the determinants of a matrix, which is very important, and determinants of a matrix is important to find the inverse of a matrix as well. In order to find the inverse of a matrix, this is the formula: inverse of a matrix, which is adjoint of that matrix divided by the determinants of that matrix to give us the inverse of a matrix. Okay, after getting inverse of a matrix, and then inverse of another matrix B, and then I want to find the problem number G, which is finding the rank of a matrix. Rank of a matrix means if there is a matrix, if columns does not depend on the other columns on the matrix, or row does not depend on the rows or other rows of the same matrix, then that matrix is called the full rank matrix. For example, the matrix A has a 3 rows and 3 columns. If one row cannot be obtained by any type of mathematical manipulations, then that matrix has the rows that are linearly independent. So they do not depend. It's called linearly independent. I previously said um, if if the rows of matrix A does not depend on the rows of matrix A, other rows. For example, matrix A has 3 rows: 7, 5, 4, 9, 8, 5, 2, 7, 4. If first row 754 cannot be obtained by linear operations, by the linear operation of other 2 rows 985 and 274, then matrix A is called the linearly independent. So that means full rank. It has a 3 independence row. Similarly, 3 columns, if they cannot be manipulated or changed, that means one column cannot be obtained by the linear combinations, linear operations by the others, then that is called the linearly independent column. So let us check by running this. We want to do inverse ranks. If you take a look at that, it has a rank of 3. Okay, it has a rank of 3. On the other hand, I want to write it is a rank of 3. For example, let me show you another matrix. Let me show you another matrix that will not have a rank 3. I want to write another matrix like D, that is 936, right? 936. From the 9, if you divide by 3, then it will be 3, then it will be 1, then it will be 2. For example, I created a matrix D on line number 64, where row number 2 can be obtained, row number 2 can be obtained from row number 1 by dividing row number 1 by 2. So that means row number 1 and row number 2 depends on each other. If I multiply row number 2 by 3, then I will get row number 1. Okay. Now take a look at this. If I want to find that one, you will see the rank is 2 now. Now if I want to change here D, let me run this one. Let me run this one first. And then I want to find the rank. You will see rank is 2 now. Why? Because row number 2 depends on the row number 1, or row number 1 depends on the row number 2. If I multiply row number 2 by 3, we will get row number 1. Or if I divide row number 1 by 3, then we will get row number 2. So rank means number of independent rows or number of independent columns. That is what known as the rank. Very important for predictive modeling. Okay. So let me comment it here. Following matrix D rows of matrix D are not linearly independent. Okay. Transpose means rows will be transposed to the column or columns will be transposed to the row. So this is the previously it was 754 in the row. If you take a look at that 754 in the row, now 754 is in the column. 985 was in the row, now 985 is in the column. 274 was in the row, now 274 is in the column. So transpose mean transposing a matrix, transposing the rows or columns of a matrix. If a matrix has a uh, if we use transpose operations over a matrix, then rows will be converted to column. That's the meaning of the transpose. So this is another rectangular matrix where there are three rows and two column in matrix P and two rows and three column in matrix Q. I want to run these two matrix and then want to find their multiplications and multiplications by a number 9, creating a identity matrix. That means all elements of the matrix has 0 in off diagonal positions and has 1 in the diagonal positions. This is the unit matrix. All elements of the matrix are units. This is a 0 matrix. This is a 0 matrix. This is a So this is the let me consider problem number 8. Problem number 8 is asking you, we want to solve this system of linear equations. Okay. So 3x plus 4 equal to 5, 7x minus 3y equal to 7, where I want to solve for the x and y. Similarly, for the three equations with three unknowns x, y, z, we can solve this. How can we solve this? Problem number 8. So problem number 8 we solve is, there is a two unknown x comma y, system symbols x and y, and before that we have to import this package. After importing this package, we have to write 3 4 5. 3 4 5 as the 3 4 5 are the element of the first equations. 7 3 7 are the coefficients or second one. So that is the way you will write your unknowns. That is the way you will write the coefficients of the equations. And finally, you have to solve like this way, linear solve. And finally, you get the solution like that. This is the same approach, but for the three unknowns, you get the solutions. Okay. After doing this, now we want to compute some basic computations, sum of 100 numbers. This is the sum of the 100 numbers. Okay. This is the sum of squares of the 100 numbers. This is the mean deviations from mean, which is always equal to 0, mathematically, which can be proved. If you do not understand these things, how this could be true, I can show that in very quickly. For example, mathematically, what I am finding in question number 11 is this one. Question number 11, what I am finding. Question number 11, what I am finding is this. Why mathematically this is equal to 0? sum of xi minus x bar. Okay. So it could be written of sum of xi minus, I'm summing over a constant. This is a constant I'm summing. How many times I'm summing? I'm summing it n times. I equal to 1 to n, I equal to 1 to n. So, and then we know x bar equal to sum of xi over n. So total equal to n times x bar, sum of xi. So this is the cross multiplication, we got this. So here we got n x bar, and this is a constant, no suffix is in there. So this is the n times x bar. So that's cancel equal to 0. So that's the reason this summation is always 0. And then it is a mathematically I have shown in here, when this is done, this is equal to 0. Question number 11. Question number 12 equal to uh, mm, sum of square divisions. Sum of square divisions. Sum of square divisions means I am taking divisions square. So that means sum of square divisions. Okay. Sum of square division is that one, which will be a big number. And then question number 13 is asking you summing two different quantities. Question number 13 is asking you this. Okay. And question number 14 is asking you again to sum two separate quantities, which is equal to that. Let me see. 13 is that, and 14 is this. This is the 14. And then question number 15 is asking you, if you plug I equal to 1, then the numerator will be e to the power 0 and denominator will be 11. So that's the way you have to find it. Question number 15, you are getting this one. Sum I equal to is taking 1 to 100. That's the way you are getting it. Okay. On the other hand, if just these things is be written, so there is the hundred quantity. Okay. So if you don't believe in this, let me plug it in there. 1 over 11, right? It is the power, if you want, 1 over 11. Let me check whether that is true. If I plug in here 1, then it is 0 equal to 1. 1 over 11, 1 over 11, 0.0909. So take a look at that, 0.0909. And then let us check the last one. Let us check the last one. Last one will be what? Last one will be, if I plug 100, e to the power negative 99. So that will be NP e to the power negative 99, e to the power negative 99 divided by 110. That is exactly these things. These things is exactly equal to that, and these things is exactly equal to that. This is where I equal to 1, this is where I equal to 2, I equal to 3, I equal to 4, and that is what I equal to 100. So if we add them up, then we will get this result. Okay, we will add them up, then we will get this result. Okay. 15 is done. We have 15 more problems. Let me clean it up. If you want to clean it up, that's the way you can clean it up. Okay, now come after 15. Now we want to go for the 16. I equal to 1 to n e to the power minus xi plus 1 divided by xi plus 10, where xi takes 100 values from random integers 0 to 999. Random integers 0 to 999. 16. So I took a random seed. Okay. What does means random seed? Why we need these things? Because suppose one student is randomly generating something, another student is randomly generating something, another student is randomly generating something. As the generation is random, your result will be different. But when I will grade which one I should give the full credit. Okay. In that way, because randomly generated, all of you are arguing, Professor, I am right, I am right, I am right. Why? Because you are randomly generating, the answer will be different. So in that case, there is a solution that if you want to generate some results from randomly, then if you set the seed, if you random seed, if you specify this one, so one student put 110, another student put 120, another student put 200, another student put just 59. And by running this, if he randomly generate that and give me the random seed, then if I run the code, I will get exactly what he get. Okay. So in order to replicate the exact same result, random seed is a essential part. In that case, whatever result you have got, I will get the exact same result if I use the same random seed. So in this case, I am generating random dot random integer. I am generating 9 to 900 9999 random integer for the range 100. So in the question it is said where xi takes 100 values from random integer 0 to 999. 0 to 999, I want to generate 100 random numbers. So that 100 random numbers will be different for all people around the world. But how can we regenerate exact same result? How can we replicate? How can we do the same results? We can do same results by just simply running random seed, and then I run that one. So now if x equal to this is the number. Okay, this is the number. Now take a look at that. If I again do these things and write x, now see this generation will be different. Are you seeing 318, 365, which is different from 959? But if I write the random generator, and then if I now run it again, and now if I hit, are you seeing 956, 397, 956, 397, 183, 813, 813. So that means if you set up a random seed and generate something, it will give you same result. So I hope you understand what does random dot seed means. Random dot seed means if you want to conduct an experiment where randomly you are generating the data and you are getting the result. In that case, if you set the random seed, the results that you generated, and if you get the code as well as random seed, someone in the Australia, in Japan or Europe or Canada or other parts of the United States, he can exactly generate whatever you have generated. I hope you understand. So now I want to, after generating 100 numbers, I just want to sum this up, which is very easy, which we already did. Only difference is 100 random number from 0 to 99. So now I just need to run this one. So that is the results. Okay. Now question number 17 is asking you, I want to find the summation and multiplication of this pattern. See, pattern has a mean 1 plus 2 over 3, 2 over 3 times 5 over 4 over 5, 2 times 3, 4, 5, 6. So it is a two-step increase in the number, in the numerator as well as in the denominator. So we have to create a sequence That, and then after creating the sequence, we have to multiply them, and then we have to finally add them together. So there is a pattern. If there is no pattern, if no pattern is in there, then what you will have to do? You have to manually write the sequence. You have to manually write the sequence if there is no pattern. As there is a pattern, so we have to write the code so that that patterns, that sequence could be generated. How can I do that? Take a look at this one. I think view horizontal speed. I can like this way. Let me see. I can do the vertical speed. Yeah, vertical speed. Then in that way, you have a bigger screen now. Okay. So now I want to clarify these things. 17, I have to create this sequence. How can I do that? I am writing a function of argument n, and then ai equal to 1. Now I am writing a loop for I in range n. This n is this argument then. ai minus 1 equal to ai. Position in the series before summations. X underscore numerator. So numerator, what I am doing? I am doing 2 times I plus 1. If you put here I equal to 1, then it will be 4. I equal to 2, then it will be 6. I equal to 3, then it will be 8. This is the way numerator sequence. And denominator sequence, how can you do that? X numerator plus 1. X, whatever I'm getting in numerator, I'm just adding in here. These two lines of code is creating the denominator and numerator sequence. Let me tell you, this is 2, 4, 6, right? 2, 4, 6. Take a look at that. X numerator 2 times I plus 1, X denominator, X numerator plus 1. Because denominator 1 is bigger than the numerator. So denominator 1 is bigger than the numerator. So whatever number I'm creating in the numerator, I'm just adding 1 to that in order to make it denominator. So that is the way we have done this. Now I just write it updating the values of a at index I. So ai minus 1 times x numerator divided by x denominator. So this is ai minus 1 equal to ai equal to 1. I have created here ai equal to 1, and then I am updating these things like that way. And then finally, I want to get the return. Finally, I want to get the return of that ai. So now, okay. So now I am putting in here series F17I for I in the range 20. I in the range 20. Why 20? 20 times 2 equal to 40. So if I take you there, there will be like this. Actually, 20 times 2 equal to 40. If you put here 19, then it will be stopped at, see, F17I series F17I for I in the series like this. Now, if you just write the series, this is the all series. And then finally, if I want to sum this, then it will be the summation of that series. So again, I have started with the first element, and first element, what I did, record the previous ai minus I equal to ai, which I declared in here, and then that I looping numerator and denominator I have written in here ai minus 1, and then finally I got this. Okay, so now come in here, question number 80. This is called the double loop, but the loop does not depend. This is an independent loop, so which is easy. J takes I equal to 1 to 5, J takes 1 to 5, I takes 1 to 20, and I want to sum this. So I am taking in here, so I created a J, I series and J series. I takes value 1 to 20, J takes value 1 to 5. So I created I series and J series 1 to 20, 1 to 5. And now I am creating this one, this for J in J series, for I in I series, order of the loops. So whether you are putting I or J, that doesn't matter. Then if you sum this, you will get this result quickly. Much easier. Okay. Alternative approach is for I in the range 1 to 20, for J in the range 1 to 6. And then if you total, you will get this one. Same results. So in this case, what is happening in here, if you write here I series, I just want to write here I series, you are getting 1 to 20. So in order to get these things in Python, you have to write here I 1 to 20, because otherwise they will do what? They will go 0 to 20. Now it will 1 to 20. So if you run it in here, let me see, just range it in here. So what I want to mean in here, when you write 1 to 21, they are actually taking value 1, 2, 3 up to 20. Because if I write here other way, then they will write here like 0, 1 to 20. Now 0, 1 to 19, but now they will write here 1 to 20. That is the way Python you have to write. Otherwise, the desired result you will not get. Okay, question number 19 is this one. This is little tricky because the J values depends on I. Whatever value I is taking, J is taking on that range. So this is the easiest one. I in range 1 to 11 and J is in range I equal to 1 to I plus 1. So that is the way J is loop, like I is looped within J. I has been put within J because I is like J is taking up to I values, whatever highest value. I highest value is 10, so J is highest value is 10. So now if I want to put here I equal to 1, we will get 1. I equal to 2, I equal to 3, I equal to 4, I equal to 10. So that is the way it is running. For example, you have to, if 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 I am asked to write like this way, so let me write it so that you can understand what does this mean. It's the question number 19, right? Yeah, question number 19. Question number 19, it has been written, j equal to 1 to I, j equal to 1 to I, and I equal to 1 to 20, I equal to 1 to 10. I to the power 4 divided by I to the power 4, I to the power 4 divided by 3 plus ij. 3 plus I times j. Okay. So if I am asked in here to do these summations, what I will do? I will do I equal to j equal to 1 to 1, 1 to the power 4, 3 plus 1 times j plus I equal to 2, 1 to 2, 2 to the power 4, 3 plus 2 times j plus j equal to 1 to 3, 3 to the, I am plugging now, I equal to 1, I equal to 2, I equal to 3, 3 plus 3 times j. That is the way you have to finish until it stops in 10. J equal to 1 to 10, 10 to the power 4, 3 plus 10 times j. So that is where I part is done. So here, this is the way, if you are, I am asked you to compute this manually, that is the way you have to compute these things manually. So you have to compute this part manually. Now, I put I in the range 1 to 11, j in the range 1 to I plus 1, and then total. So that is the easiest way to understand. And the next alternative one is little difficult because for j in range 1 to I plus 1 and for I in range this, and then you are doing double summations, first sum and then second sum. So you will end up with the same result in here, total. And then if you run this one and do the total, you are getting the same results, almost same results. Okay. So now come to the question number 20, which is just very simple problem. Which is just specifying the numbers and then adding them up. Now go to the question number 21. So in this case, take a look, there are two unknown, x and n. What they have mentioned in here, write a function and give it a name, foo1, which takes two arguments, x and n, where x is a single number and n is a strictly positive integer. The function should return the value of this. So what we will have to do, what we will have to do, we have to write a function that will have two arguments and consider n equal to 10 and x equal to 10 at the end. But I have to write a function for this one. So which has a two unknown x and n. And if we write this as a function of two arguments, and then at the end, we can just put the two argument value and get the results. So take a look at that import numbers. This is a package, and I'm writing a function that has two argument x and n. X assert is instance, numbers real. X must be a real number. This function does not accept a number and less equal to 0. Okay. And greater than. This is the assertions. This function does not accept non-integer values. So that means n must be an integer value. If n equal to 1, then return equal to 1. Results 1 plus x to the power I divided by I. X to the power I divided by I. Whatever power in x, exactly same thing in the denominator. So that is why x to the power I divided by I for I in the range 1 to n plus 1. Return results. So this is, are you seeing n, are you seeing x? This is the argument of this, and these are all assertions. So we are making sure that x could be real number and n must be an integer. If n equal to 1, the result is always 1. For example, if I plug n equal to 1, you do not need to go all the way in there. Okay, it is just always the answer is 1 if n equal to 1. Okay. So now return result is I am trying to find these values. So that is the answer. That is the answer. I want to draw this function where x takes value less than 0, x takes value 0 and 2, and x takes value greater than 2. Under these three conditions, x value takes values like that way. Okay. Okay. First of all, I have said very clearly in here, write a function temp fn. This will be the name of the function for this one, which takes a single argument of x. The function should return the vector of values of the function evaluated at the values of x. Hence, plot the function for this. So -3 to +3, I want to generate how many numbers? 1000 numbers I have generated. -3 to +3. So take a look at that one. I have generated that many numbers, and it is evenly spaced from that. Now I am writing a function, temp function xi. If xi less equal to that, return this. If xi greater than 0, less than 2, return this. If xi greater than 2, return this. This is the way I have written the function. So the function has been written. Now I have temp function np dot vectorize this. This is just the vectorizing these things. And now fx equal to this x that I generate, so when you input a list or array, the new function will apply the function to each element within it, similar to how a for loop works. So now write this. This is the fx for all of those 1000 values. Okay. All of those 1000 values that I have put in there. So this is the values. Now I want to find a plot. This is the plot. Okay, so that's the way we have seen the uh, how to how to how to do a plot for a step function, mathematical step function. So this is the step functions. So the functional range values, functional domain values. This is the functional values. X is the argument, and fx is the range. So how to plot this step function by using Python, which we have learned. This is 23, same as the 19 that we previously did. Now let me do the next one. Same results. Okay, so after this is just how to create a different pattern, right? I have to create oh, two vectors x and y by randomly selecting 100 numbers with replacement from this. And then I want to create a pattern like this way. This way I can create the pattern. So take a look at that. This is a n equal to 100. This is a random 100 number. That is a random another 100 number coming from 0 to 99. Now I want to create a pattern like this way. This is one pattern. That is another pattern. And but read the questions. The reason I am discussing these things down the road, sometimes you have to create a pattern like this way, or some mathematical function that are generating in this pattern. How can you create these things? So this is the way you have to create the pattern. And then number C is this type of pattern. That is the summing. If you do not do the sum, I just don't want to do this. Just write the sum. These are the pattern. These are the pattern we are getting. And if you sum it up, you will get like that way. So here, create a 6 by 10 matrix of random integer chosen from 1 to 10. From this matrix, do the following. Find the number of entries in which in each row which is greater than 4, which row contains exactly 2 consecutive of the number sevens. So that could be done by question 25. So here is the thing. So first question is, create a 6 by 10 matrix of random integer 1 to 10. So random integer 1 to 10. So low is 0, high is 100. Not inclusive of 11. Okay. So now if you write it in here, control enter and take a look at this A. Right here A, you will see this is the uh, matrix. 1 to 10. So if I want to write here, I can write here 1. Then if I do this, then if I write this, these are 1 to 10. Okay, these are 1 to 10. And after doing that, now what we want to do, matrix has been created. Find the number of entries in each row which is greater than 4. Which is greater than 4. So now, total greater than 4, A greater than 4 dot sum x is equal to 1. A greater than 4 gives 1 if AI greater equal to 4. Otherwise 0. So and then we are summing it up. So now the question was find the number of entries in each row. So that is why we are summing. That is why we are summing in here. And I gave a very good explanation in here. Similarly, exactly 2 rows. So A equal to 7 dot sum x is equal to 1. Uh, A equal to 7 if AI equal to otherwise 0. So this line of code will be very important because suppose if you have a big data you are analyzing and from that big data you want to pick up like you want to pick up whether 2 occurrences, 3 occurrences, exactly 7 occurrences. How can you do that? You have to run you have to run these lines of code. You have to from the big data from by row you have to pick 2 occurrences or exactly 3 occurrences among the rows, then you will pick only those rows. That's the way you can subset the data by using these lines of code. So this is done. And then 26, 27, 28, 29, 30 are just the integrations which we are using. We are using a package and then we are writing is integrand and then A. Okay. So that is the way you can do any integrations. I import the package and I write the function that I need to integrate and I integrated it like this. Okay, so I think that's it. So this is the first week materials for basic computations. Please practice all of these basic computation part at least 2 times and then try to solve the homework which will be similar to this type of problem and try to understand how Python works. And there is also a Jupyter notebook if you want. Some people like the Jupyter one because that is block wise. You write the code block by block and everything will be in there. But I prefer the spider one because that has a similarity with the R. Okay, let me stop in here. And next week, from the second week, we will discuss big data analysis. Okay, bye.